Tucker. I've downloaded some new software onto my little netbook at home, and I wanted to make a series of videos to help you guys get ready for the TAKS test. All of these questions that I'm going to use in this series of little video clips all came from released TAKS tests for the 8th grade. So these are all the type of questions you guys will see on the TAKS test. So my first strategy here is called process of elimination. I know you guys are very familiar with that. Let's get started. Alrighty. Let me grab myself a pen here, and I want to make it bigger and I want to make it blue. Okay. This strategy, process of elimination, here's the first question. Triangle EFG, this one here, EFG, is similar to triangle HJK. It says find the length of JK. JK is this length right across here. If these two triangles are similar, then side lengths are proportional. And if I look at this length here, 10.5, compare it to 21, I know this side over here is going to be bigger than this smaller side here. So this JK length has to be bigger than the 3.5. It can't be A because A, 3 units, is smaller. If you look at some of the other answer choices, it can't be D because D is way too big. In fact, 24.5 units is greater than 21, so it can't be that. And I don't know if you guys noticed, but if you take 10.5 here, and if you double it, you get the measurement of 21 right there. So I'm going to take this 3.5 and double it, and when you do that, your length is 7 units. So it can't be 14. 14's way too big. And my answer here is B, 7 units. Now, just to double check, I think I'd go ahead and set up a proportion and make sure, but you'll find that your answer is B, 7 units, and I will see you in the next video. Go with some more math TAKS testing strategies. Still working on process of elimination here. I've got another problem for you, so let's take a look at this one. Okay, in this problem right here, it says the equation C equals 0.75T represents C, the total cost of T tickets on a bus. Which table contains the values that fits this equation? They didn't give you a lot of information here, but if we're talking total cost and number of tickets to ride the bus, then 0.75 represents the cost for each ticket. 0.75 or 75 cents for each ticket. Okay, let's take a look at the answers that they gave us. Well, if you think about it, if you're only buying one ticket, it's only going to cost you 75 cents. So right here, that one works. And let's see, that one right there works. This one says $1.75 for one ticket. It can't be C. And this one also says $1.75 for one ticket. Can't be D. So we know that it's either going to be A or B. All right, if I buy 2 tickets at 75 cents each, I know it's going to be $1.50. There's no way it's going to be $1, so it can't be B. The answer has to be A. That was an easy one. I'll see you in the next video. I'm sitting here in my home, cooking a little dinner, making a few math videos. I'm good that way. So here we go with the next video. This one here says, a bag of mixed Yummy Gummies contains 26% green, 34% red, 24% blue, and 16% yellow gummies. Carla put 250 mixed gummies in a bowl. Which proportion can be used to find Y, the total number of yellow gummies in the bowl? Here again, I'm going to use the process of elimination strategy. Let's see where that gets us. We're talking the yellow gummies. So if I go up here, let's see, it said that there was 16% yellow gummies in the bowl. Well, I know that that means 16 out of 100. Let's see which one of these proportions has that part set up correctly. Okay, right here on A, I see 16 out of 100 there. That looks good. 16, the 100 over 250, that isn't going to work. I know it's not C. Let's look down here at B. I've got 16 over 100 over here. That's good. And I've got 16 over 100 here. So I've eliminated C. All right, if I know that percent over 100 is part over whole, and I've got a total of 250 mixed gummies in a bowl, that's my whole. So 250 is the whole. That goes down in the denominator on the other side of the percent, or I'm sorry, the proportion. So let's see if we can find 250 in the denominator. Well, right here 250 winds up in the numerator. It can't be A. Let's see, here we've got 250 down in the denominator where we want it. And in D, I don't even see 250 anywhere. I don't know where they came up with 150. It can't be D. And so using process of elimination, I know the answer has to be B. All right, good luck with this strategy. See you in the next video. Little estimation can get you a long way. All righty, so here we go. Here's our problem. In this question, it says, oops, I was trying to grab a pen here, and I was trying to make it the right size and make it the right color. Alrighty, here we go. Mr. Daniels surveyed the students in his science class about the type and number of pets they owned. The table shows the results of the survey. Alright, we've got type of pet, cat, dog, bird, and fish, and number of pets, 30, 90, 60, and 150. Alright, which circle graph best represents the type and number of pets reported by the students in the survey? If you take all three of these here and add those up, 30 plus 30 is 60, so 90 plus 60 is 150. I can tell that fish are going to be 1/2. You guys know that circle graphs are used when you want to represent data as percents, so I know my fish is going to be 50%. Now, doesn't that look like a kindergartner doing that? I don't have my inner right pad here at home. Fish has to represent 50% on my circle graph. Okay, this is estimation, and I'm also going to use process of elimination here. Fish looks like it works out okay on A right here, because that's 50% on A. It looks like it's not going to work on B, because that shows 75% fish, so it's not going to work there. Looks like we have fish at 40% and dogs at 50%. Well, that's not going to work. Let's look at D. D, we've got fish at 50%, so I know it's either got to be A or D. Alrighty here. If you look at the number of cats and the number of birds, they're the same at 30%. So both the cat and the bird wedges have to be the same size, and they're going to be the smallest wedges because the next largest wedge is going to be dogs. There's 90 dogs there, 30 cats, 30 birds. So I want dogs to be the next biggest slice, with cats and birds both being the same size. And if you look here, I've got dogs and cats being the same size, but I want cats and birds to be the same size. So I don't think it can be A. If you look over here, I've got dogs at 30%, birds and cats at the same size at 10%. I know my answer's got to be D. Well, there you go. Good for us. Again, I'm redoing this video on estimation because I'm recording this at home and I got a phone call in the middle of the video. So here we go again. Let me switch this over so we can see the problem. The strategy we're using is still estimation. It says the results of a random survey showed that 42 out of 80 people plan to vote for Mr. Vu for City Council, which is the best prediction of the total number of votes he will receive if 2,000 people vote. Okay, I don't have my inner right pad here. I'm going to try to set this up. I know, it looks like a kindergartner's writing this. If 42 people out of 80 plan to vote for Mr. Vu, if I'm going to estimate, that means I'm allowed to round. So I'm going to round this to 40 out of 80. And 40 out of 80, isn't that 1/2? I just love comparing things to a half. Is it bigger than a half? Is it less than a half? Is it close to a half? Well, in this case, 42 out of 80 is very close to a half. And if we're trying to figure out the number of people that would vote for Mr. Vu, if 2,000 people vote, well, 2,000 is our whole. We're trying to figure out the part that would vote for Mr. Vu. And if it's going to be a ratio of 1/2, one person for every 2 vote for Mr. Vu, then I know that the number here that would vote for Mr. Vu would be half of the 2,000 or 1,000 people. Now, if you set up your proportion and actually use 42 and cross multiply and solve that way, the answer comes out to be a little bit bigger than 1,000, which it should be because 42 is a little bit bigger than 40. Alrighty, we'll see you in the next video. Hi guys, here I am making another math tax video again. I'm still working with the estimation strategy. I found us another problem, so let's take a look at it. All right, let me grab a pen color that I like here. Oh, it's going to be ornery here. I'm doing all of this in paint because I don't have my InterWrite pad here at home. All right, the problem says, Miss Gonzalez's monthly electric bills for March through June were $97.09, $103.96, $114.73, $121.82. She estimated, oh, there she goes, she's estimating. She estimated that the electricity cost a total of $400 over these 4 months, which best describes her estimate. Okay, let's see here. This number right here, I'm going to switch pen colors here real quick. Okay, see this one right here? If we've got 4 different bills, and she got 400 over 4 months, that means that it looks like all of these were rounded to 100. Okay, so this one right here, the 9709, she had to round that up to 100. Oh, let me grab another pen color here. The 103.96, she rounded that down to 100. The 114.73, she also had to round that one down to 100. And let me grab another color here, something that's going to show up nice. The 121.82, she also rounded that one down to 100. So there was only one that she rounded up by about $3, and all of the others were rounded down. This one was rounded down about $22. This one was rounded down about $15. This one was rounded down about $4. Okay, it says which best describes her estimate. A, it's less than the actual amount because she rounded the nearest 100. B says less than the actual amount because she rounded to the nearest 10. Well, that's not right because she rounded to the nearest 100. If that was 100, that was 100, that was 100, and that was 100, that's how she came up with the 400 over 4 months. So it can't be B. So here we are also doing a little process of elimination. More than the actual amount because she rounded to the nearest 10. No, that's not right. And more than the actual amount because she rounded to the nearest 10. No, that can't be right. You know what? I'll bet I made a typo here. I'll bet one of these was supposed to say to the nearest 100. You know, I think that's right. I think I made a little typo when I was, let's call that 100 right there. One of them said 100, and one of them said 10. And one says less than, and one says more than. Okay, so let's say that we have a choice between A and D now because we know that she rounded to the nearest 100. Okay. It says which best describes her estimate. Is her estimate going to be a little bit lower than the actual or a little bit higher? Well, since she, on most of them, on 3 of them, she rounded down, then her estimate's going to be a little bit less than the actual because she rounded to the nearest 100. So it's going to be less than the actual amount because she rounded to the nearest 100, and A is going to be our answer. There you go, guys. See you in the next video. Estimation strategy to help you out with your math tax test this year. Let's take a look at this next problem. All right, this one says This season, Joe has made 65% of his free throw shots. What is the probability that he will make the next 3 free throw shots? If we're trying to calculate the probability of consecutive events happening right in a row, I hope you guys were all listening. We need to multiply here. So we need to multiply 65% by 65% by 65%. We either need to convert those to decimal form or to fraction form. So I decided to play around with some fractions here, and let's see if this is going to work for us. Yeah, there we go. All right, I've got 65% multiplied by 65% multiplied by 65%. And you know, that 65 over 100 is not easy to work with, so I decided right here I'm going to round those down. I'm going to do a little front end estimation, round 65 to 60. So I've got 60 over 100 being multiplied by itself 3 times, which simplifies to 6 out of 10. When I multiply that out, I get 216 over 1,000, and if I change that to a percent by dividing the top and the bottom both by 10, I get 21.6 out of 100, or 21.6%. So that's the low end, because I rounded down. Here, I've rounded up a little bit. I've changed 65 over 100 to 70 over 100, so 70% times 70% times 70%. When I simplified that, I got 7 tenths times 7 tenths times 7 tenths, multiply tops times tops and bottoms times bottoms. You get 343 out of 1,000, and I want that as a percent because my answers are all in percent form, so I'm going to divide the top and the bottom by 10, and I get 43.3 out of 100. Did I say 43? 34.3 out of 100, or 34%. Now take a look at this. I've got 21.6% on the low end and 34.3% on the high end. And if we take a look at our answer choices, I believe you're going to find that the answer is B, 27%. Of course, now you can back that up. Do the math. Take 0.65 times 0.65 times 0.65, and I bet you find out that your answer is B, 27%. See you in the next video. Tucker, yes, making another math video, waiting on my chicken to bake. Okay, I got another, I don't know if this is so much a strategy as it is maybe a type of TAKS question that you'll see on your math TAKS. Let's take a look at it. Okay, I call this prove or disprove. This type of question, you have to go through and read each answer and either prove it to be right or disprove it. And don't stop at just the first question. Hello. You need to read each one of them and either include it as a possible answer choice or cross it off. This question says Lily surveyed all the members of her middle school band about their favorite class this semester. The results are shown in the table below. Okay? It says, from these results, Lily concluded that band was the favorite class among all the students at her school. Which is the best explanation for why her conclusion might not be valid? Do you guys remember when we talked about sampling methods, and biased is bad and unbiased is good? Well, we want to know why her conclusion might not be valid or why it might be biased. So I'm going to go back up here and look. It said Lily surveyed all the members of the middle school band. Look at who she surveyed. And look at what the favorite class was among those surveyed. Well, guess what? The favorite class was band. You wouldn't be in band if you didn't like band. Okay, let's go through and prove or disprove each answer choice. A says the survey should have been done each day for a week. Yeah, I don't think that's it. I really don't think that has anything to do with it. B says the sample was not representative of all of the students at the school. I would agree because she only surveyed people from the band. C says the survey should have been done with 8th grade the survey should have been done with 8th grade students only. It says she surveyed all the members of the band. It doesn't say anything about 7th grade versus 8th grade, so I don't think that's it. And D says the band meets only 3 days per week. That has nothing to do with this question. So going back and looking at it, I don't think it's going to be A, the survey should have been done each day for a week. I don't think it's that. I think the reason why this might not be valid is because the sample wasn't representative of all the students at the school. It was only representative of the people in her band class. So B is my answer choice here. Was it your answer choice? I knew it was. See you in the next video. Guys, Mrs. Tucker again, working on those TAKS videos so you get a good score on your math TAKS test. Let's take a look at a little bit of averaging here. Found you a problem. All right, in this problem right here, it says Jasmine has an average of 95 on 15 quiz grades. If her teacher drops Jasmine's lowest grade, a 72, which equation can be used to find N, Jasmine's new quiz average? Not certain why it is, but this kind of question seems to show itself on darn near all the TAKS tests at the 8th grade level that I've seen. So it'd be nice to go over this one so that when it shows up on yours, you'll get it right. All right, Jasmine had an average. Always read the question 3 times. Once to get a gist of what it's about, second to pick out the details, and the third time when you think you have an answer, read it one more time. Right, Jasmine has an average of 95 on 15 quiz grades. It says if her teacher drops Jasmine's lowest grade, what's the new average? Well, if she's going to drop the lowest, doesn't it go from an average of 15 quizzes down to an average of 14 quizzes? So when she calculates the new average after dropping her lowest quiz score, we're going to be dividing by 14 and not 15. So let's take a look at our answer choices. Here we're dividing by 14. Here we're dividing by 14. Here we're dividing by 14. I know it can't be this one because we won't be dividing by 15, so it can't be C. Okay. It says, let's see, she had an average of 95 on 15 quizzes. Well, you know, to get that 95, an average of 95, you had to add up all of the quiz scores and then divide by 15. Okay, if she's going to drop the lowest, a 72, don't we need to have the sum of all 15 quiz scores and then take out the 72? Well, let's see here. That says nothing about the total sum of the quiz scores right there. This one right here we're taking, we've eliminated C. 72 subtract 15, that's her lowest score, subtract the number of questions. That doesn't really make any sense. Right here we're taking 95 and multiplying by 15. Well, she did have an average of 95 on those 15 quiz scores. So if you took an average of 95 and multiplied by 15, you would have the sum of all the quiz scores. Now we can subtract the 72, which gives us our sum for 14 quizzes, and then divide by 14. So I know it's not D, I know it's not A, it looks like the answer here is B. And this is called put yourself in the situation, because I had to kind of talk myself through, see myself actually calculating the average on 15, and what it would take to then drop one and recalculate an average for 14. So, we'll see you in the next video. Guys, it's Mrs. Tucker broadcasting live from the Tucker kitchen. Yes, I am still making dinner and still making math TAKS videos. And I got another problem I wanted to share with you. Isn't math all about looking for patterns? Let's take a look at this question right here. All right, it says the figures below have a repeating pattern, which shows a 180-degree rotation of the 19th figure in the pattern. Okay, I've got figures 1 all the way up to 12, and all of these look like little isosceles triangles, and they're all pointed upward. If the 19th, if we want to show a 180-degree rotation, that's half a circle, that one would be pointing downward. And there's only two here that are pointing downward. So I know it can't be A, and I know it can't be B. So it could be this one, it could be C, and it could be D. All right, here, let's see. From figure 12, then there's going to be figure 13, 14, 15, 16, 17, 18, and 19. And the thing that I've noticed in the tip of each one of these isosceles triangles, we do have a pattern happening here. Here I've got a dark, here I've got a dark, here I've got a light, here I've got a light. Here the tip is dark, here the shape is dark. Here the shape is light, here the shape is light, dark, dark, light, light. This one's going to be dark, this one's going to be dark, this one's going to be light, that one will be light, dark, dark. Guess what? The 19th one is going to be light. And this is the tip here, and this is the tip here. Looks like a kindergartner drew that. I think it's going to be D because it follows the pattern. It can't be C because I need a light tip, not a dark tip. Well, that one was easy to do. I kind of like that one. I hope you enjoyed that. I'll see you in the next math video. Hey guys, Mrs. Tucker again. Working on another one of those math TAKS strategies. Guess which one we're working on this time? Yes, find a pattern. Let's take a look at the next question. Okay, this one says a baseball card was worth $3 when it was issued in 1996. The table shows the value of the card each year since 1996. Based on the information in the table, what is a reasonable prediction for the value of the baseball card in 2004? All right, 1996, 1997, 98, 99, 2000, 2001. We want it all the way up to 2004. So I would look to see how is the value of the card increasing from year to year. Let me try to do a little cut and paste here. See if this will work. Oh yes, that's beautiful. Okay, here's the table that they've given me, and I've added a little bit to it. Okay, let me put this in the screen here so you can see it. Alrighty, and I'm going to see if I can grab a pen. All right, we're all about looking for patterns. So from this year to this year, this increased by 30 cents. 0.30. From here to here, from 97 to 98, that increased by 35 cents. So let me write that in here. From here to here, that increased by 40 cents. I'm starting to see a pattern here. From this year to this year, that increased by 45 cents. From 2000 to 2001, that increased by 50 cents. Okay, so now I know what my pattern is. It's the value of the card is increasing by 5 cents each year. So this is going to increase from here to here by 55 cents. This will be 60 cents. And from here to here is 65 cents. So if you figure that up, 2004, that card should be worth somewhere around $6.75. I want you guys to do the math yourself, make sure I didn't make any mistakes. Now I want to see what my answer choices were. And I'm not certain how to undo all of this besides doing this. Let's get rid of this. What did we say? The answer was somewhere like $6.75. I would say the answer is between $6 and $7, and my answer choice is B. I want you to work that problem and see if you don't agree with me. Good luck finding patterns, guys. See you in the next video. The 8th grade math TAKS test, they can be challenging. I know you guys can use percent proportion. I'm confident that you know how to use it. Let me show you a different way to think about a problem here. Let's take a look at this one. All right, This one, I love it when the percentages are even, big numbers like 40%, because there's a lot that we can do with this. Okay. All right, this says Bobby saved $32 when he purchased a jacket at a clearance sale. There's my daughter walking in. It says if the sale price was 40% off the regular price, what was the regular price of the jacket? Okay, well, you saved $32, and that was 40% off the regular price of the jacket. All right, here, let me do a little cut and paste here. All right, let me put this down here. It says that 40% off was a savings of $32. Okay, well, if $32 represented 40%, then a 20% off that jacket would represent half of this, since 20 is half of 40, $16 savings on that jacket if it had been 20% off. All right, well, what if it were 100% off the price of that jacket? Wouldn't that be the complete price of the jacket, the original price? What'd you do to 20 to change it into 100? You multiplied by 5. So if we take 16 and do the same thing and multiply by 5, 100% of the cost of that jacket is 80. And 80 is one of our answer choices. If I were you, I'd go back and I'd set a percent proportion. 32 would go in the numerator, and you'll be solving for the whole price of the jacket, which is X in the denominator. Go back and check that and see if you don't get $80 for the price of that jacket. See you later. Hi guys, got another math tax strategy for you. Sometimes these questions just involves knowing your math vocabulary. Here's a good example. All right, this one says a polygon. We've got polygon PQRSTU is shown on the coordinate grid below. Which coordinate grid shows a reflection of the polygon across the x-axis? There's two vocabulary words here that you need to know. We need to know what reflection means, and we need to know which one's the x-axis. Okay, reflection is a mirror image, and I know you guys have no problems with mirror images. The biggest problem is figuring out which one's the x-axis, and in my picture, the x-axis is labeled. This came off of an old TAKS test, so it should be labeled should you see something like this. Here's your x-axis. So if we're going to make a mirror image of this figure across the x-axis, it's going to look something like this. So let's see here. It's not this one, because that's a reflection. That's not even a reflection. That's a translation across the y-axis. This one is not it. This is a reflection, but that's across the y-axis. This right here is not it, because this is a translation across the x-axis. And this one looks similar to the one I drew. The answer is D. You got to know your vocabulary terms. Good luck with that. Hope you've been paying attention in class. It's me again. Got another math tax question for you. Let's take a look at it. This one has to do with math vocabulary again. It says a dentist kept a record of the number of new cavities his patients had per year for the last 10 years. The scattered plot below shows the average number of new cavities per year for patients in the 4 to 32 year age range. Which description best represents the relationship of the dentist's data? It says F, negative trend, G, no trend, H, positive trend, J, cannot be determined. You need to remember what each one of those means. Negative trend means that we're decreasing from left to right. No trend means the data is all scattered out. There was really no pattern, something like that. Positive trend means that it's increasing from left to right. And if you look at this one, there is a definite decrease from left to right. So we've got a negative trend here. Hi kids. I think I've got one more video here for you for the moment. I call this strategy, I listened to my math teacher because she's oh so much smarter than I am. Here we go. Let's take a look at this problem. Okay, a cell phone tower has a transmission range of 50 miles. A cell phone tower that has a transmission range of 50 miles is located 40 miles due south of a straight road. Do you see this picture right here? That means that the radius of the circle is 50 miles and it's located 40 miles south of this road. It says find x, the length of the section of road that is within the transmission range of the tower. We want to know this total length all the way from here to here. But you notice that in the diagram we've got what type of triangle here? Yep, that's right. We've got a right triangle. And anytime you have a right triangle, you know you should be using what? Oh, she's not going to say it. Pythagorean theorem. Oh. Say it.
Pythagorean theorem.
That's right. Okay. Now, if you'd been listening to that oh so smart math teacher of yours, you would remember your Pythagorean triples. Here is your most basic right triangle. It's a 3, 4, 5 right triangle. And all of these other lengths here are based on 3, 4, 5. If you take 3, 4, 5 and multiply each one of those by 2, you get a 6, 8, 10. Well, look what happens if you multiply each one of those by 10. You get a 30, 40, 50 right triangle. Well, look what we've got going right here. We have got a 40 and we've got a 50. So, guess what this length right here has to be? That's right, that has to be 30. So the entire distance across here is going to be double that, or 60 miles. You can go back and double check that with Pythagorean theorem, and guess what answer you're going to get? That's right, answer C, 60 miles. Good luck using those Pythagorean triples. I know they'll work for you. Hi guys, I've got another math TAKS strategy for you. It's looking for clue words. Let's take a look at this example. Okay, this example says, a bicycle wheel travels about 82 inches in one full rotation. What is the diameter of the wheel to the nearest inch? All right, we've got some clue words here. I have been talking about this clue word to you guys for a long time. One rotation means one circumference. If that wheel travels 82 inches in one full rotation, then that means that its circumference is 82 because a tire rotates on its circumference. Okay, we want to calculate the diameter. Go to your formula chart and you're going to see this formula. It's going to say C equals pi times diameter. Sorry, it looks like a kindergartner did that. I'm using my mouse instead of my InterWrite pad here. Okay, so 82, I'm just going to plug in what they gave me. 82 is the circumference. I think I'm going to use 3 for pi, and now I can calculate my diameter. So to calculate my diameter, I need to take 82 and divide by 3, which gives you, when you do the math, you get about 27. And if you take 27 and multiply by 3, you get 81. That's pretty close to 82. So my answer is going to be D, 26. Good for us. We know how to handle these clue words. See you in the next video.
I always feel like a dork when I do this. Oh, I'm recording. Oh, okay. Hi guys, it's Mrs. Tucker again. Hey, I came up with another TAKS strategy that I want to show you. So let's get started. All right, you're working your TAKS test. This is an old TAKS test. So, whoops, what happened here? Did it scroll? Oops. Oh, there we go. Let's use, well, no, that's not the one I want. I want this page right here.
Okay, now.
Okay, there we go.
Click on, yeah.
There we go. All right, now I'm back to where I want to be. All right, I'm working my TAKS test. Number 17, I know this is Pythagorean theorem. I know I got the answer correct. I know it's 17 without a doubt because I've showed all my work. In the margin, I want to put a smiley face because I know without a doubt I got this one right. I don't need to come back and look at it. Okay, so I go on to 18. I think the answer is the mean, but I'm not really certain. I'm going to put a question mark in the margin. All right, I go on to number 19, and this one looks hard, and I really don't want to start off with the hard ones. I think I'm going to skip this one and come back to it, so I'm going to put a star by it. Now, when you get to the end of the TAKS test, guess which questions you're going to go back and work? That's right, the ones with the stars by them. Use all your strategies, see if you can work it out. I'm sure you can. When you're done finishing all of those that have stars by them, then I want you to go back and take a look at the ones that you put question marks by. See if you can't come up with a different strategy. See if you want to stick with that answer, if you want to change it. And I call this the smiley face strategy. Now, on your TAKS tests, there's going to be 50 questions that are going to be graded because there's going to be 10 extra questions that aren't. But 50 of them are for a grade. If you want to get commended, you have to get 45 of those 50 questions correct for commended. All right? If you just want to pass, you've got to get 30 out of the 50 to pass. So that means very bare minimum, we're looking at 30 smiley faces. Of course, you know, what if you're wrong on one of those? You won't pass. We want to shoot for as many smiley faces as we possibly can. We should be shooting up in this 45 range. Try to get as many smiley faces as you can. That way, when you leave the test, you'll feel pretty confident that you passed. Thanks for watching this video. When I come up with another strategy, I'll definitely share it with you.